Hello everyone. In this video we will see how to design a static CMOS circuits. Basically the CMOS is usually we have as a PMOS and NMOS. And always the PMOS is used as a pull-up network. PMOS is pull-up network. Why it is pull-up network? Why it is called as a pull-up network? Because as a NMOS cannot able to pull the full VDD to the output side. Likewise, PMOS cannot pull the ground, pull the zero completely to the output side. So that's the reason we should always call the PMOS as a pull-up network and NMOS as a pull-down network. Always we will place PMOS towards a VDD side and NMOS towards a ground side. So we know the basic inverter. The basic inverter will be having a PMOS in the upside and NMOS in the downside. So if you want to know more about the inverter, please, I have given the link in the description. You can check over there. So now we will go for static CMOS circuits. For complex circuits, how it can be designed. So for example, if I want to design for A plus BC, if I want to perform for A plus BC, then if it's multiplied, if it's dot, A plus B dot C, I want to implement this function by using CMOS circuit. So if there is a dot, then PMOS will be in parallel, Always the PMOS and NMOS are complementary. Always it will work in the opposite direction. So PMOS is in parallel means NMOS will be in series. Likewise, if there is a plus symbol, is there, then PMOS will be in series. And NMOS is complementary, so NMOS will be in parallel. So this is the basic rule for to design basic complex logic functions. If it's a dot, then PMOS will be in parallel and NMOS will be in series. If it's a plus, then PMOS will be in series and NMOS will be in parallel. Let us take an example over here. I have taken same A plus BC. So now in this first example, whatever is inside the bracket, we will do it first. So BC is the first. So dot means what? I have told that PMOS will be in parallel. So you can see here, this is a B input and the C input. Both PMOS are in parallel. Whereas in the NMOS side, you can see both B and C are in series condition. Then we have implemented the BC, then plus A plus. So if plus means what? I have told that the PMOS will be in series. So you can see here the A is series with the BC. A plus BC, where BC is dot, so it is parallel, where A is plus, so it is in series with your BC, whereas in the NMOS it's complementary, so the A is parallel with both B and C. So this is how you can design a complementary function. So in the output side, it will provide the complementary output. A plus BC bar will be the output. So always suppose for example, if you want to design A plus BC normal value means, then you put an inverter in the output side, so you will get A plus BC. Whereas here in this complementary output, you will get A plus BC bar. Suppose if you want to get A plus BC, then put a NOT gate over in the output side, you will get the proper output as A plus BC. So I have given we need to give the 3 input pulses. So in the normal VDD I have given 5 volt, and then for A I have given a pulse value as a 5 milliseconds on time and period is 10 millisecond. And then in the second pulse I have varied the on time of 7.5 milliseconds and period is 15 milliseconds. Because why I am varying this A, B, C means I need to get the output for all the combination 0, 0, 0, 1, 1, 0, 1, 1, 0, 0. We have 3 input variables. So 0, 0, 0, 0, 0, 1 up to 1, 1, 1, 1. So I should get all the different combinations so that I have given different on time and period. And in the C I have given 2.5 milliseconds and 5 milliseconds. So it's up to you people how we are going to vary the inputs. So now let us run this program. So the inputs are A, B, C and output. So this is output. Let us right click and then add plot pane, right click, add plot pane, right click, add plot pane. So V of A, V of B and V of C. So now here 1 1 1 the output is 0, and then 1 1 0, and then 0 1 1, and then here 0 0 0. So for all the combinations you can see the corresponding output as a plus BC complex function. So likewise you can do for lot of logic complex functions, and likewise you can use a basic logic gates also by using static structure CMOS. So usually if you are going to perform an basic any gates, suppose if we are having A plus BC means we are using 3 variables, so it requires 6 number of transistors. Always static circuits require 2n transistors, where n is the number of input variables. So for A, B, C, for 3 input variables we require 3 PMOS and 3 NMOS transistors. So usually we require 2n transistors for static CMOS circuit design. So likewise you can try it for basic logic gates for NAND, NOR, XOR, XNOR. Likewise you can try it for, and then you can try it for a bit of complex function as A B plus CD or A plus BC into CD. Likewise you can try it for lot of complex functions. Thank you for watching.